So let's define values of trig functions based on what we've kind of done before. You will also be asked to simplify some trig expressions. Okay, and that'll help us to verify later on, that'll help us to solve later on. So to simplify, we're just going to use the algebra that we're going to use the algebra that we've done in the past and just kind of use what we know to simplify the expression. So I'm going to rewrite expressions in terms of sine and cosine only if possible. All right, so if I have an expression that has cotangent or secant, I'm going to try to switch everything to sine and cosine. Usually those are easier to recognize when we're trying to verify or simplify expressions. Another tip we can kind of look at is maybe I can't switch everything to sine and cosine, or maybe it doesn't really help. Another thing I could do is just rewrite everything in terms of one trig function. Maybe I have a secant squared and a tan squared. I'm going to go back to my fundamental identities here and say, well, what do I know about secant and tan? Can I somehow replace one of those secant squared or tan squareds with the other so that I have an expression with only one trig function? It's just easier if I have one trig function to work with. Okay. And then last, sometimes you have to factor to kind of simplify expressions as well. We'll just kind of look at that and see if factoring helps, then I'm going to factor. Likewise, if I had a fraction, if simplifying that fraction or writing it as one fraction, getting common denominators helps, we're just going to do all the algebra that we know how to do. Okay? So let's start. We have simplify the trig function. We're not verifying anything, we're just simplifying, which means we're trying to find an equivalent expression. Okay, so there can be a lot of different answers because equivalency means I've just rewritten the expression into something that's also the same value. Okay, so here we have tan x times cosecant x. Now my tan x is the angle. I'm not looking for the angle per se. I'm just trying to take this expression and rewrite it. Is there some way I can rewrite it? So what I would say is let's look at tan and rewrite it in terms of sine and cosine. So we know that tangent is sine x over cos x. This is an equivalent expression for tangent. Okay. For cosecant, I'm going to do the same thing and rewrite an equivalent expression for cosecant, which would be 1 over sine. All right, so we're just multiplying these two expressions. I rewrote tangent, I rewrote cosecant, and now with my algebra skills, I know, okay, if I have sine x times 1 over cosine x times sine x, I could do a little bit of simplifying. I could simplify now or I can wait till the end, but I'm just going to do it now. Sine x divided by sine x cancels out. It's just 1. So now I have 1 on my numerator and cosine on my denominator. Okay, so this is an equivalent expression. Could I do more? Could I rewrite even this expression? Yeah, I could keep going. 1 over cosine, if I look at my reciprocals, the reciprocal of cosine is secant, so this is also just secant x. Okay, so I have all these equivalent expressions, and when we're simplifying, that's all we're really asked to do. Generally, it's take a big expression and just simplify it down if you can to a smaller expression. Okay. All right, let's try another one. So this one says sine theta, secant theta, plus cosine theta times cosecant theta. Now again, theta could be x, it could be y, it could be theta, beta, alpha, gamma, it could be any letter in the English or Greek alphabet. So that's just my angle. We're not looking for that. We're just looking to take this long expression with 4 different trig functions and try to simplify it down to something a little smaller. And again, I'm going to take that suggestion of let's just rewrite everything in terms of sine and cosine. Sine is already written in terms of sine. I don't need to change it, right? Because it's already written in terms of sine. But secant, on the other hand, can be rewritten as 1 over cosine. All right. And then I'm going to do the same thing here. Cosine is already written in terms of sine and cosine, right? It's cosine itself. I don't need to change it. But Cosecant can be rewritten as 1 over sine. All right, so now I have an equivalent expression. It's not simplified because it's still 4 terms. I still haven't really done anything to simplify. I've just rewritten the terms in the trig functions in terms of sine and cosine. So now I can say, okay, sine, this is like sine over 1. Sine times 1 over 1 times cosine. So sine theta over cos theta. Plus, same thing here. This is like cosine over 1. So cosine times 1 over 1 times sine. Cos theta over sine theta. All right, so I've got all these equivalent expressions. My job is to try to simplify. So I'm just going to keep going until I get to something that looks a little more simplified than what I started with. We can use the fact that sine over cosine is tangent. So I'm going to rewrite this to tangent. And that's a nice thing about rewriting expressions is we have the freedom to kind of rewrite into anything that's equivalent. Okay, so we don't have a direction to go into right now. We're just rewriting into equivalent forms. Whatever we recognize, we rewrite and use that. Cosine over sine is cotangent theta. All right, so now I have an equivalent expression. It is a little more simplified. There's only 2 terms that I'm adding, 2 trig functions that I'm adding together, so it's simplified. All right, let's try one more. And this should get you through Monday's assignment. Cosecant squared x times secant squared x minus 1. Now remember we said anytime you see a squared, you try to say, well, is there some way I can simplify that down by using one of the Pythagorean identities? So if I look at the Pythagorean identities, we're trying to simplify, make things smaller, and I have cosine squared. So if I look at that, cosine squared, and we did say we could manipulate that and write it in this term, but it makes my expression bigger. 1 minus sine squared. I don't want to make it more complicated, right? So I'm going to leave cosine squared alone. But if I look at secant squared minus 1, then I come here and say, okay, I have something with secant squared. It's not minus 1 right now, but I have something with secant squared. Is there any way I could rewrite this so that it says secant squared minus 1? So let's take this one and look at it. So I'm just going to rewrite it here. We have 1 plus tan squared theta equals secant squared theta. My expression says secant squared minus 1. So if I take this 1 and subtract it from both sides, the 1 will go away and it'll be on the left side. On the right side is minus 1. So I'll end up with tan squared equals secant squared minus 1. And that's exactly what would help me. I have this in my expression. Now I know it's equal to just tan squared. So I'm going to rewrite my expression. Instead of secant squared minus 1, I'm going to rewrite this as tan squared. We didn't change the cosine squared because it would have made my problem look a little more complicated, and I don't want to complicate things. Now we can say, well, why didn't I change everything to sine and cosine? Well, our tip was whenever you see that squared, see if that will help you. See if the fact that this is some type of Pythagorean identity, see if that'll help you simplify. And it did. I had cosine, and then I had a secant squared minus a 1. Now I've at least taken this binomial and written it down as a monomial. Okay? And now I can use the rule of, well, let's rewrite everything in terms of sine and cosine. This guy, again, it's already in terms of cosine. I don't need to change anything here. But tangent, on the other hand, can be rewritten as sine squared over cosine squared. Right? Normally we say tan is sine over cos, but because it's squared, I need to make sure I'm squaring the numerator and denominator. All right, and now I can use my algebra skills. This is like cosine over 1. Let's simplify. Cosine squared divided by cosine squared cancels out to 1. And I have sine squared on the numerator, 1 on the denominator, which I don't really need to write. So So I can simplify it all the way down to just sine squared x. So this long, complicated expression actually simplifies all the way down to just sine squared x. Okay. All right, so I'm going to stop for now. That should get you through Monday's work, and then the second video will take you through the second half of chapter 5.1.